Yeah. So now your record button worked. Perfect. Awesome.
Okay, so now let me share my screen so we can look at this
So let's start from
analysis.
the Google Drive, and you got to march through a lot of stuff to get here.
Mhm.
So go to it's the click on My Drive on your side there, because you need to get these in order, because there's a folder you're not. Oh, stress analysis there. Okay, it's there. Stress analysis. Open that one. Now open the folder at the top. And now there's a couple of that will work here, but the ZZ integrated shows it most clearly.
Got it.
And then open the graphs total 9 assays up there. And if you open them, you can get them larger, or just zoom in on those a little bit. There you go. Now, so there's a lot of different ways. So we're moving through a lot of different levels of movement. So distance moved is the denominator in all or is the y-axis on all these that we're looking at right now, right?
Mhm.
And then which type of fish are going across the bottom. So if you roll up just a little bit, and you'll see the titles on the bottom on the x-axis.
Here.
Right there. Right. So vehicle alone, that's your control. Then it's with ibuprofen, with Dilantin, with the 3 different levels of mammalian bradykinin, and then 3 different levels of zebrafish bradykinin. Right. Now notice he's done something tricky in that those orders, because it was looking for the leading number. The order of concentrations aren't in increasing value, because 10 nanometers, then 100, I'm sorry, 10 nanomolar, then 100 nanomolar, then 1 micromolar.
Mhm.
But right now you see how the 1 micromolar precedes everything else, but that's actually
Yeah.
the highest amount
Mhm.
concentration wise in each, because that would be 1000 nanomolar, right?
Yeah. Yeah.
So so at any rate, this is a bar chart version with a the variability, and I'm not sure what the variability of it, if it's I'm not sure what the variance is measured as, if it's standard deviations, or if it's standard error. I don't know. I'll have to ask him that. But you see that there is a bar, because you have a number of fish under each of these conditions. So you've got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 fish. He's doing this, I believe, in a 96 well plate. So I'm going to assume he has 10 of each, but I don't know. So question 1 for Han is, how many fish per treatment?
How many fish per? Okay.
Because you see, you've got that control, but that's not one fish you're looking at.
Yeah.
You're looking, the error bar shows you that you're looking at a collection of fish, and I think it's 10.
Got it.
But it could even be multiple plates and be more than that, because I gave him about 100 per treatment group.
Okay. Got
Yep.
it.
So I need to know. So the first thing we need to know, but do you understand what these 3 columns are? So this is a cumulative number of movements at baseline, and then after and then he's doing, I don't know what dark 1, dark 2 are on this page. Down a little bit, because this is that I haven't looked at. I don't know why dark 1, dark 2. Oh, so so basically that's his washout. So that's later down the road that he's doing a secondary treatment to bring them back down. Okay. So it's basically return to normal, if you will.
Okay.
So it's basically baseline, excited, and return to baseline. But I think I do want to understand exactly how long did they go after the initial light. The light was 1 minute of light on, and then the light went out between the first gray box and the second gray box. Does that make sense?
Yeah.
So you have a whole bunch of fish. They're sitting on a light table. There is a camera above it like this, and it's all in this soundproof room. Okay, or relatively soundproof room. And basically they start the camera and they can film as much background time as they want. So that's the baseline. During that period of time, the fish are moving around as fish sometimes do. They're each singly in a well, so they're not near each other. So sometimes they'll choose to start exploring the environment, and sometimes they won't. So that base level of movement is occurring. And then a really bright light turns on for a minute and then turns off. And that throws them into immediate excited stress. So they start producing cortisol like right away. And that's this higher level of movement. But because each fish is a little bit different than one another here, you're going to see that there's more variability, because meaning fish 1, fish 2, and fish 3 of the same condition may be slightly different in the way they respond to that light on. So you see a broader bar overall, right? But in general, you're seeing that the fish get excited by the light, and then they come back to something that represents normal.
Yeah, back to the baseline.
Right. So we can look at this in a lot of different ways. In this case, this is a large amount of time. And I'm betting it's 8 or 10 minutes, or even if it's just the first minute, this is all of the movements in a minute. And I don't know how many minutes, right? So it's binned by the minute. Now, if you go to the tracings, it's doing smaller subsets of time. So how he buckets the time changes how this looks on a graph. Because if I turn around and say I had 10 fish, and in second 1, this fish moved, in second 2 and 3, this fish moved, in second 4 and 5, that's a really complicated tracing. But if I turn around and say, how many millimeters did this fish move in a minute, it starts to even out to look like a smoother overall trace. Does that make sense?
Yes.
And so a lot of what Hans' group has done is been to spend time to see how do we best bin this time in a way that it captures what occurred. We don't lose data, but it captures it in a smooth enough way that we can see trends in what's occurring. So keep paging down.
This is the last one. This is page 4.
Okay, go back then to my drive.
Do you want to look at this one?
Yeah, choose this one. Yeah, and this is the one I have open. That's why it threw me. So you're going to see, again, you're going to see mean distance moved in millimeters per minute, but this time at each second.
Okay.
Do you see how do you see how it's a tracing? And again, this tracing at each second might have a broad array. And this is as compared to what you just looked at, baseline and excited, baseline and excited. But what I would do is I would choose one way of showing the data. And I think so keep paging down, keep paging down, keep paging down. Like this, stop right here, up a little bit, go to this tracing gives you a good feel for what's happening, right? Because each of those lines, you can see how there's a whole bunch of data points in that second, right?
Yeah.
For each color, right? So there's the shaded area that shows all of the data points. So whether that be 10 fish or 20 fish or 50 fish, and I need to know that answer, and I don't know. So we have to put that question together for Han. But here, I can look at this, and I would probably make this figure, figure XA, right? I think this is the A part of your figure, because this shows that the experiment worked.
It showed that we got the movement and the stress. We were able to measure it.
Yeah, if this stayed along the bottom line and you never got that jump, that peak, nobody got excited that it didn't work. And that's what happened last time we ran this with this group. We ran it and he came back and said the assay didn't work. But so all of the fish seem to have reacted to the light treatment with a stress response. So this is a good control, or overall view of the. Now let's go down to the next one down, and it gives us the data then in a really nice way, and it's statistically treated, right? So here we see the baseline for each, and then we see the excited for each, and we note that vehicle, the blue on the right side graph, the red, the green, and the purple are all basically the same. It's not until we get to the zebrafish bradykinins that we have something that's statistically different that we see through the ABC. So we get A, if you will. So technically, all of those last three and the top mammalian one, page down just a little bit. I want to make sure if that's the mammalian one I'm saying. Oh, no, I'm just trying to read that the lettering on the x-axis. There we go. Hold on. So I see mammalian bradykinin, the low level of mammalian seems to also have hit that level, but that's not that important. But basically, we're seeing that we had a difference in what we need now is the asterisks up here, but the lettering tells us. So D, all of these are the same on the left side, right?
Mm-hmm.
All of those are statistically equivalent. Yes, some are a little higher and some are a little lower, but statistically, they're all the same by ANOVA. In the second one, we see that we have a relationship between bradykinins starting. So we see that ibuprofen and Dilantin are not different than the vehicle alone control. They have C in both cases. They're also not different from each other. Then we go ABC. So the bradykinin mammalian, first, second, and third one are not different. They're all still have a C. So they are not statistically different than vehicle alone. Mm-hmm. They are not statistically different than one another. And they are not statistically different than bradykinins, than Dilantin and ibuprofen. All right. We get to the last three, zebrafish bradykinins. At the highest concentration, they actually had the lowest effect.
Yeah.
But they do start to show a unique effect, that showed up a little bit, but they really still can't be discerned from the control. But at the other two concentrations, they are discernible from the control.
Yeah.
Does that make sense? So specifically at the 10 nanomolar level, they're discernible from the control and all other treatments. And so it means they moved more, but moving differently, whether more or less, either way would have been important.
As long as we got the movement.
Right. So statistically, what this means is that these are identifiably statistically different than control, adding the zebrafish bradykinin at the 10 nanomolar concentration. Now, questions I would ask Han would be to say, how does this compare to other known factors that act as stressors or stress enhancers in zebrafish, so that I can better put this into the context of understanding this assay? Now, I guarantee Han is the most conservative person you're ever going to meet. So he's going to be like, well, obviously we got to run this again. So, because it's interesting, but let's repeat this experiment. And I agree with him. See if it plays out again. We're dealing with several different compounds that that breakdown in light. And so the longer they were on our bench, the more they were just becoming the equivalent of adding water. So adding very fresh stock right before the experiment could be important to seeing if we can even make this look more of a difference. But generally speaking, we don't accident upon statistical significance, right? So I think this it appears interesting enough at this point to rerun the experiment. It does appear that the bradykinins are directly being related to a mental health outcome, as in a stress response. Is that what we would have? That's what we were asking. And so it's supportive of our hypothesis. If we wanted to do this even better, we should actually look at it in the context of an interleukin-6 or something like that, a cytokine. So I don't think we'd have to, I don't see anything interesting about ibuprofen or Dilantin in this. And so I don't know why I'd waste fish to do that again.
So you just want to rerun the bradykinin?
I might rerun the zebrafish bradykinin, but run it side by side against a cytokine like interleukin-6.
Okay.
To me, that's a really good follow-up experiment. But in general, all this is, have I talked about this being like a first-person shooter situation?
Yeah. Yeah.
Because that's what it is. I mean, basically, you're standing here in a room, and in this case, the light turns on, but it could be a loud bang or a shot or anything like that, and you have a moment to decide what to do. In this case, we know that reproducibly, when there is that moment, zebrafish will do one of two things: freeze or run. Right? And so statistically, generally speaking, we see that almost all of our fish, when that light turned on and then back off, ran. All right. And so the question is, did they run farther faster than other people running from the same thing? So meaning, did they accelerate and get even more stressed than the light alone would explain? And the light alone explains the level that we see as dark blue on the left side of the right side of this thing. And yes, they did. They moved more than was expected by the light alone. So which means they are somehow being acted upon by something different. In this case, we know that the only thing different that we added to their system was that zebrafish bradykinin. So it appears rational to believe that there may be a connection between bradykinins and a stress response. So a scientist will always say, I'm going to see if I can reproduce this data. I'm going to run it again. I'm going to run it with more numbers. I'm going to run it cleaner, right? I might want to do a larger, now, because I'm going to eliminate, I think I'm going to get rid of the mammalian, and I'm going to get rid of, I kind of like the mammalian in that they're kind of like a scrambled control, but I'm not going to get into that right now. But if I get rid of the ibuprofen, the Dilantin, and the mammalian, and then do a broader continuum concentration curve of the bradykinin, and then do something very similar with an interleukin-6, then we would know A, if it has an effect, and B, if that effect is concentration dependent.
Okay.
For your figure, I honestly think a picture of a plate. So a picture of a plate might be A, this might be B, and that might be C, D.
Okay.
And I literally think that's it. Now, making your figure legend is going to be hard and require you to put together a series of questions for Han. Does that make sense?
Yeah.
But I don't think you need anything more than that. I think those are really, that's enough.
It's because we've seen how the bradykinin has reacted with the fish. So now we have an idea. We know that we don't want to work with ibuprofen and Dilantin. So we're just
we don't see a response to them.
Yeah. So we're just going to move to a kind of, okay, so bradykinin has worked. So now we're going to broaden the effects. We're going to see what concentration works. At what point does it become not effective? What point does it become effective? And how are we going to move it from there? Right. And we're going to be giving them the different conditions.
So this is the challenge that tonight when I had everybody together, this is what I'll put up a picture like this. So like the one that you've got up there, and I'd say, okay, let's play the game of making as many objective statements about this as we can. And I can see like the dark red line is higher than the blue line. It appears that the ibuprofen is higher than the
Ibuprofen is higher than the Dilantin. It is higher than the. Wait, am I looking at the right one? Some of the colors.
So maybe I can't say that. So maybe I can just say all fish, all treatments appear to have reacted to the light stimulus. That might be the only objective thing I can really say about that, right? I might be able to say the range of distance moved in millimeter per minute for all treatments was from about 5 to about 60 millimeters per minute. So you see, so I can practice. Those are all very objective things I can say about this. Now, interpret what can I interpret about that? The experiment worked. So my interpretation statement from this graph is to say, it appears that as the control and all other treatments responded to the light, that this was a worthwhile experiment and I should look deeper into the individual data. So now roll the next one up. No, the other way. Right there. I said, what can I say objectively about this? I can objectively say all treatment groups were statistically equivalent to one another, meaning in baseline, no group stood out as different than one another on baseline movement. Once startled, zebrafish, specifically zebrafish at a 10 nanomolar concentration, caused statistically significant increase in overall movement. A trend toward higher movement can be seen across all concentrations of zebrafish bradykinin, and potentially some at the lowest level of mammalian bradykinin. But do you see how I'm not making broad, those are just objective statements.
Objective, very vague.
Right. Well, I don't know if that's vague. I mean, I can get all down to each, I can talk about each one individually. I could even say that the vehicle control changed. I can say that it changed from approximately 5 millimeters per minute to just under 18 millimeters per minute on average. The ibuprofen changed from an average of 6 to 7 millimeters per minute to 19 millimeters per minute. So I can make dozens of those types of statements that are very specific. Now, what does this, so that's the difference of my, so that is my, what am I trying to say? That's my analysis data. That's my data section, right? So my data show that there was an increase in movement in all samples, and specifically statistically, there was a difference between the zebrafish bradykinin treatment of 10 nanomolar concentration and the baseline control and all other samples. So now I go on to my discussion. So that was my result. What was my discussion says, it appears that there might be a relationship between zebrafish bradykinin and the stress response. Now, future goals. An interesting trend appears to be showing itself based on concentration level of the zebrafish bradykinin. It may be of value to look at multiple concentrations with higher number of fish to establish whether this response is concentration dependent. Secondly, because the bradykinins are showing a reaction, it would be worthwhile to consider how this compares to the known reaction of cytokines with the stress response. So future experiments may wish to include interleukin 6 or another known cytokine from that response, from that inflammatory response. So, truth be told, I probably only need to use a small paragraph to describe all of these 4 sessions like that. But like I said, I think I would ask for a really nice image of the setup with the plate in place, and Han should be able to provide us with that. I think I would then also, like we've got the questions with regard to how many fish per treatment in this situation, and what he thinks the next best step is. And, so I think you should put together a list of questions for him and have him answer them directly. And then you should prepare a figure and share it with him for his revision.
Okay.
But I don't think the figure has to be complex at all. It could literally be taking exactly from here. Anywhere he's got, you might want to, if you go through, the raw data are there and you can build these individually such that you have more control over the font sizes and stuff like that. Because if you go back to my drive, you'll find the spreadsheets.
Yeah, right here. Or sorry, it's just else right there.
Yeah.
What's the difference? Oh, okay.
But there's so much data there. Like I said, I stuck to the great big pieces of it. But if you put together a set of questions, then I'll reconnect you guys and have him come back to you first by email, and then if he wants to join us by a call.
Okay, sounds good.
Is that fair?
Yeah.
Are you closer?
Yeah. I mean, talking to you, it helps me just interpret the data a lot more, so I understand what we have, what we're going to be doing moving forward, and regarding that, the experiment did work. And
that's the number one thing. You get to look at that first graph and say, good, it worked. Good. Now the second thing is,
how do we make it better?
Because it was known, keep in mind, out there, we already knew that cytokines could have this response. There's much less information on bradykinins showing this level of response. So long term, somebody's going to be asking us to compare this to cytokines. Because if we're going to take the stance in our poster and eventual paper that this is a bradykinin, we're trying to mimic a bradykinin storm, well, then we better be able to show how that compares to a cytokinin storm. That's all. I mean, but otherwise, everything seems positive.
Yeah.
All right. So am I going to see you tonight?
Yes.
Awesome. Between now and then, if you happen to get some of those questions put together, the faster we get them to Han, the faster he'll answer them.
Sounds great.
Fair enough. All right. See you later.
All right. Later, Chris. Peace.